so this would be the last part of the tutorial. So we start with question 13. Okay, they give you 12 microwatt of sound power passes through the two surfaces. Okay, they give you two area, this one and that one. So you can assume maybe that one is a circle or something. Doesn't really matter, or square. Okay, maybe I try to draw the diagram. Okay, so this is the source of the power, sound power, which is 120 microwatt. Okay, it passes through surface area, which is A equals to 400 and 1200. Okay, so you know that power is equals to intensity divided by intensity is equals to power over area. So you can calculate I1 and I2 respectively. Okay, but you can convert to meter square. Okay, so one deci to meter is 10 negative 1, but since this one is square, becomes 10 minus 2. You can try to do the cross multiply if you want to. Okay, so your I is equals to power divided by A. So for I1 it will be the same power supply, 120. So I1 here I got 3 times 10 negative 5. And I2 will be same power, but the area is different. So you will expect that the intensity will be lower. So I got here 1 times 10 negative 5. Okay, and don't forget to write down the units. Since this is power divided by area, it will be watt per meter square. Watt per meter square. Okay, so for question 15, question 14 we already discussed. An organ pipe of length 33 cm is open at one end. So that one will be your L. I change straight away to meter. Calculate the frequency of the fundamental and the first overtone. So let's say this is your fundamental, and the first overtone would be your n equals to 3. Okay, because this is the open n, so you have to use Fn equals to Nv over 4L. And remember that this one is the odd one, where n is equals to 1, 3, 5, and so on. So your fundamental is n equals to 1. The first overtone would be n equals to 3. So the drawing is a bit misleading here. I'm going to change it to the more appropriate one. Oops. Okay. Oh. Okay, it should look something like this. Okay, where you have 3 and 3/2 lambda in the first overturn. Okay, so to calculate, you don't have to actually draw it. You can simply use the formula as long as you understand the concept. So V here, you have to use the speed of sound. So only for string that you have a special V, but the remaining you just have to use the given speed of sound. Here I'm going to use V equals to 331. So your F1, this one will be F1. 1331 divided by 4 multiplied by 0.33. So I got here is 250.76. Okay, and I can calculate the F3, which is equals to 331 got here 752.27. So this one is frequency, so the unit will be in hertz. Okay, that was for question A. For question B, length of an open pipe and having is equal to the difference between the two frequencies. Okay, they want you to find the length. Okay, so question want you to find L if open pipe fundamental frequency equal to the difference between the two frequency. So open pipe is something like this. Okay, and it says that the fundamental where F1 is equivalent to the difference between F3 and F1 just now that we calculate. So it will be 752.27 minus 250.76. But here's 501.51. Okay, the unit will be in hertz as well. Okay, they want you to find the length, so this is open pipe, an open pipe. So you'll be Fn equals to Nv over 2L. You have to use this formula. And since F1, so N will be 1. So L here is equals to 331. Substitute the V divided by 2, and I'll bring down the F1, which is equivalent to 501.51. So that here is 0.33 meter. Okay. And for the last question, a variable length air column is placed just below a vibrating wire. The length of the air column opens at both ends. So that they do, satu is this one, opens at both ends, another one is string. So it's gradually increase until the first position of resonance. So F1 is observed when L is equals to 34 centimeter, which is 0.34 meter. Okay, notice that I always change the SI unit straight away. The wire is L equals to 1.2 meter and vibrating in third harmonic, so F3. So for the bottom one, you have to use, I think both of these basically you have to use the same formula. where Fn equals to Nv over 2L, where n equals to 1, 2, 3, and so on. And this one is the same formula. Remember that only open one n, you have the weird one, the odd one. Okay, dia kata the length, okay. Okay, so you do have the length over here, and you do have the values of v, which should be given, which is 331. Okay, we use the previous value. Okay, and if you substitute all the values there, since we're talking about the try to read again. Okay, yeah, so you have to substitute n equals to 1, so you can calculate the frequency first. Okay, you should get 21 multiplied by 2 divided by 2 divided by 0.34. Here's 486.76. It says that the frequency at resonance means F1 for open n is equal to the F3 string. Okay, so that means at resonance the frequency is the same. Itu maksud dia lah. So F3 equals to NV over 2L. Okay, remember that this one, the V here, is the speed of the transverse wave in the wire. So it's no longer a speed of sound. So you want to find that V. The F3 is equivalent to F1, right? So that one is equals to 486.76. This is n equals to the third harmonic. And the L is given, so it will be 1.2. So if you calculate the V, 389.41. Okay, so that's it. Thank you.